Or show shots of me. It's going to be awesome. So part of what I want to do today is just see if there's any questions, but also I want to break the camera. Cool. All right. I'm going to do a little bit out of this here too. I brought some copies in case you haven't got this book here yet. So we're going to do a little group work. So chapter 1, if you noticed on the homework sheet, I assigned a review section, but then I have 2 specific sections that I want to go over. One of those is exponents and order operations. And the other one is kind of an intro to variables. So those 2 I want to specifically look at a little more in depth. But I desperately need you guys to help me figure out where you had trouble with the first homework assignment. So if you haven't gotten into that yet, you need to get into it as soon as you can. Okay. Does anybody have any questions from that first?
Question number 32.
32.
On page 94.
Were you here the other day? Probably not. Or is this math 88? Are you looking for that? So if it's not 90, this is math 88. Okay. Do you know, are you enrolled?
Yeah.
Oh, you're on the wait list. All right. And you're not sure which class you're in? Oh, that is. Yeah. Remember now, I don't think I have any room left. I'm pretty sure I took too many. But I don't know with the number of empty seats out there, but what this point. If anybody's dropped. So if you want to hang out to the end of the day, hopefully you got a plan B in place because I might not be able to let you in. I'm already in trouble as it is, I think.
I want to get you in trouble.
I get myself in trouble, don't worry. So I'm sorry, let me come back. 32.
Yes.
That's one about find the difference. No.
No, on page 94.
All right, so this is page 94. Oh, cool. All right. So hold off on that.
Okay.
That actually comes from one of the sections I want to focus on today. That's from section 1A. So just don't let me forget that we'll do that specific problem later. Cool. Oh, the seats are filling up now. Okay. Any other questions from what we did the other day, or even if you didn't do the homework, do you have anything that I went over the other day that was kind of strange for you, a topic? Yeah.
About the 2 through 88, right?
Yeah, that first assignment from the review. Oh, okay. 60? 16. From the test or the review? Oh, the one that says find the average? Okay. All right, so if I give you several numbers to try to average, we'll start off kind of nice. So if I ask you to average those 3 numbers, I got 4 people that have an idea, 5, 6, 7. So how do you do that?
Add it and divide it.
I love it. So you add them all up, and you divide by how many there are.
3.
I like it. So the idea of an average is to get a feel for, some might be larger than that number, some might be smaller than that number, but they all kind of are around that number. So the average for this, if somebody thought the average for this was 20, why are you going to look at them like they're a little crazy?
Because there's no number higher than 20.
Yeah, they're all lower than 20. The average should be in the middle somehow of the data points. Now the average is not 12, I don't mean the middle like that, but it should be sort of the number that's in the middle of all the other values. So let me give you a very concrete example of this in real life. Whenever they talk about home prices, which is obviously a big deal in San Diego, right? Or if you go out to La Jolla, you're like, really? But so I'm not going to live in those homes anytime soon. So $6 million or whatever. But whenever they talk about home prices, they don't give an average home price. They give what's called a median home price. So here, the number that's in the middle, the actual number like 12, that would be called the median. Because if there's another number up here that's really big, the average is going to be way off. So if I go to somebody, if I want to start working at a company, and I say to somebody who works there, hey man, how much money can I expect to make? And he averages everybody's income, that's not good. Because if you include the CEO, everybody's making $30,000, $40,000, $50,000, and here's the CEO making $500,000. You average those up and you tell me, you're going to make about $110,000 on average? Sweet! But it's not true. It's not. The median would give me a better feel for where everybody sort of is. You know, it doesn't let that big number get in the way. So I got a little way for myself, and I do that sometimes. But coming back to what we're worried about, the average, like you guys said, just to say it in English, add them all up. Of course, this is slightly modified English, but I'll add them all up and divide by how many there are. Cool. So here you would get, what do you get when you add these all up? 40. Good, 40. And then I want to divide by 3. And 40 divided by 3 is roughly 13.3333. You guys can check me on that. Have you guys all seen that notation there with the bar over it? Yeah, it just means I don't want to write that forever. Just trust me, it goes forever. Yeah, good. How are we doing? Is that decent? So if you didn't know how to do average, or it's been a while since you had to do average, that's how you average anything. You add them all up and divide by the number of things. Cool. Okay. Anything else from the review of the test?
The number 14, you said that it was 36?
Yeah.
How'd you get 36?
Let's see.
I got 26.
I got you. Might have been a typo in the book. I think I was just being lazy. I didn't want to try to do that in my head. Well, the book said it's 36. Let's see if the book is telling us the truth.
I got 36.
You got 36?
This is
Okay.
number 14.
Yeah. So this guy looks like this. So when you first look at this, your eyes, yeah. When you first look at this real quick, the biggest mistake people make is what makes this look like it's going to be really disgusting. When you first look at this, you might think, I desperately have to have my calculator, because your eyes kind of look at these numbers and say you're squaring some big numbers. I don't do that, but that's not what you're really doing. What are operations? What are it says to do first?
Parentheses.
You got to do in the parentheses first. Cool. And what are these? The brackets, and all they are really is just another form of parentheses, right? So I definitely want to do this and this at the end, because I want to do what's in here first. That's all right. And inside here, I treat that like it's its own little problem. I kind of forget about these for a minute. I know they're going to be later, so I don't care. In here, what do I do first?
You subtract the plus bar and get
Work the parentheses.
I love it. Now, let me help you out right now. I will always try to show you the best way to show yourself what's going on. Because one thing is, a lot of people kind of know what they're trying to do, but they don't show themselves what the hell's going on. So very often I'll have somebody trying to solve an equation, and this is coming up in our future, and they do some stuff like all over. They don't know how to bring it back together. They forgot where things were. So it's kind of like they understand a little bit about what's going on, but they just can't keep track. And that's a really kind of even more evil way to lose points. If you know what you're doing, but you just lost track, you don't want to do that to yourself. So in a problem like this, everything else you're not currently changing just comes for the ride. Do not lose anybody. Because if you don't write it now, you might forget it later. And what a horrible way to lose points. Right? So right here, all I'm doing is this, and what else? And the other one. So everything else stays there, right? Right where it is. Because 6 minus 4, there's another word for that, or another symbol, right? 6 minus 4 is also known as 2. I like the look on some of your faces. You're like, I don't have a clue what he's talking about. But all I'm trying to say is, whenever I see a 6 minus 4 anywhere in the universe, I can replace that one little thing with 2. Everything else around it can stay the same. And I haven't changed the meaning at all, right? What am I squaring? This. Well, what's this? Now I know it's 2. Cool. And of course, this is 3. And that square is still there. Everything else is still there. The only things that changed in that whole thing are those insides. Please trust me on this. Right? If you're trying to save time by not writing as much on each line, you're going to lose points. I'd rather lose time and gain points than lose points and gain time. That doesn't seem to make sense. Now, what can I do on the inside still? I'm still working in here. These are still going to be done at the end. Yeah, the squares. Cool. Right, so parentheses and then exponents. So that 2 is still there. 2 squared. Good, because 2 squared means 2 times 2. If it was 2 cubed, it would be,
2 times 2.
I love it, just 3 of them multiplying, right? So 2 times 2 is 4. 3 times 3 is 9. And that plus 10 still just sitting out there, right? So this and this have just come for the ride the whole way, right? It's the inside we're working with. And finally now I can finish that inside out. What would that become? 13. I like it. So in here now is twice 13 plus 10. And what do I do next here? What operation has to come next?
Multiply.
I love it. Not just because it's before the addition, but because multiplication comes before addition, period. So twice 13,
26.
I love it. Right? So
36.
26, and I still got that plus 10. So 36. So that plus 10 is kind of like the guy sitting outside waiting for everybody else to do all the work. Right? Plus 10. You guys done yet? No. All right. So, because I knew that addition is way at the bottom order operations, he's just going to come for the ride the whole dang way. So I don't want to assume anything, but very often what happens is that plus 10 somewhere got left off because you got too focused on other stuff. And that might be one reason why some people got 26. I don't know. Yeah. Okay. See, I've seen a few things. I understand. How do you guys feel about that? I mean, now here's the problem with mathematics and how students look at math. If you were to come in the room right now and look at the board, you would probably freak out a little bit. In fact, a lot of people would. If I leave this up on the board and the next class comes in, oh crap, they'll freak out. It looks like a lot, and especially with me adding these little arrows and crap in here. But math is all about let go of the previous line, work with where you are. Let go of the previous line, work with where you are. Very often I'll tell people, cover that with a sheet of paper as you move down. Because I think sometimes this is creeping into the thought process here. Who cares about this? Let's go on. You've rewritten it in a more concise form. Let it go. Okay, cool. Now the one bad part about this, some of you guys, equations are obviously more difficult because they have variables, but the one nice thing with equations is you can check your answer. Now this one you can check your answer still. You could actually put this in your calculator. If you put it in exactly like this, into a scientific calculator or a graphing calculator, those have order operations programmed, right? You're like, come on, why can't I just put a chip in my head and get programmed with math? But oh, if you have a 4-function calculator, you know, those with very few buttons on it, it doesn't know order operations. You have to put it in the right way. Okay, cool. All right, so any other questions on it? So today we're actually going to focus a lot more on order operations itself. Anything else from the review or the test? Yeah.
21.
On the test, find the sum.
Yes.
So that brings up a good point. There are these math words for things. So sum means what operation? Addition. Difference means subtraction. Product means, and by the process of elimination, quotient means, and that's the one that we don't see the most. Quotient, if I said find the quotient of 6 and 2, that means what do I want to do with 6 and 2? Divide. 6 divided by 2. Right, so don't let those words, it's just the same thing as saying divide these two things. So why the hell do we have to do that? Well, because we need words to describe what we're doing. So quotient means that. Let me not forget that guy. So this one just says find the sum of 15 and 107. So how do you set that up to do that by hand? Yeah, but 107, you normally put the bigger one up here. I'll tell you honestly, it doesn't really matter for addition. But we normally put the bigger one on top. It just looks a little bit more doable. And now you just attack it. All right? 7 and 5. 12. So you put the 1. And again, you guys, sometimes I get way possibly too detailed for some guys. I'm hoping you guys will realize why we carry that 1. Because in 12, 2 is in the 1's place, and there's a 1 in the 10's place, and this is the 10's place. So that's the only reason why I put that 1 over there. Exactly because of that. And then 1 and 1, 2. And then the 1 comes down. Cool. Okay, cool. Today we're also going to focus on sign numbers. Like if I had negative 107 plus 15, how would that change? So we'll focus on some of those. And we'll get a little bit into translation. Because we all should know all too well that math is a foreign language. So just like any foreign language, you have to learn how to translate from English to Mathish, right? Okay, so any other specific? Yeah.
Can you do 22?
Oh, so that's sort of like this guy, except it says, so this was 21. 22 says, find the product of 15 and 107. A product means multiplication, right? So you put the bigger dude first. On this one, multiplication would get a little bit strange if you put the small one first. It's still doable. It's a little bit weird. So we'll go ahead and put the big one first, times this little dude. And now you start to go to town on that. But now it's all about multiplying. And I don't know if I really want to get too deep into this, but if I want to multiply by 15, that means I have to multiply by 5 and 10, and then put those together. That's exactly what that process does. So we talked the other day about the fact, what happens on the second line, 5 times 7?
35.
Good, 5, carry the 3. Now, some reason here I get 8, but 5 times 0,
0.
plus 3,
3.
and 5 times 1.
1.
And of course here you need that
0.
0 placeholder, or at least an empty spot. I see people do it both ways, so it doesn't matter as long as you do one of the two. And now 1 times 107 is 107. That's whenever you got a 1 there, that kicks ass. It's the same number. That's 1 doesn't change it. And now you just add those bad boys up. 5. Yep. 6. You can always check that with a calculator, unless you're doing a test, where that part I say you're not allowed to have a calculator, right? And you're doing it without a safety net. Yep. From the test? Oh yeah. Yeah, that one. So this one says 52,000. So somebody the other day was, hopefully they're going to show me how the other way to set that up. So Russia is one country I know for sure does this, but a lot of other countries set up their division differently than we do. And that's interesting to me. I mean, one thing I want to start to get you guys to realize is that math is not the way it had to be. It's just the way it is. I mean, at some point in time, people had to make a decision. At some point, somebody had to decide what that 2 means. It was probably the guy who actually had to write 7 times 7 times 7 times 7 times. He's like, screw that. Let me just think. I'm lazy. 1, 2, 3, 4, 5. I'm going to tell everybody that means 5, 7. Screw it. And that's almost what happened. Right? That's basically what happened if you want to distill it. Anyway. What we decided somewhere in history was to set up division like this. And the reason this was a little ugly is because that 69 becomes difficult to work with, because to do division you really have to know your multiplication tables. And I sure as all hell don't have my 69 multiplication tables memorized. Right? So you sort of have to get comfortable with estimation. If this was a 70, that would be a little easier. So pretend like it's a 70 for a second. 70 would go into 500 something how many times? So 8 times 70 would be 560. Right? That would be a little too big. But 7 times 70 would be 490. So it's either 7 or 8, because I made this 70 for a second just to work with an easier number. And that's a little bit smaller. Well, let's try 7 first and see what happens. I don't know if you guys are quite with me here. The way that estimation normally works is you take the number you're working with and you make it a lot more round. Right? So 69 is right next to 70. And then I try to work with that for a second. And then it seems like 7 might work, because 7 times 70 would be 490. Right? It might have to be 8, but we'll see when we subtract. If I subtract and I get a number bigger than 69, that's telling me, oh crap, I didn't put enough up there. Cool? So what's 7 times 69?
483.
Good. And I know you all did it like that. Now what's 7 times 70? Help me out. 490, right? You got to put that 0 in front of 70. So, bear with me. And I know I personally have to be careful about reining things in a little bit when I teach you, because I always want to show you nifty little things. They're not tricks, they're just ways to do things. Human calculators, they start learning this kind of thing when I'm going to show you. If I would do 69 times 7, well, what's 70 times 7? 490. I don't have 77s though, do I? I have 1 less 7. So what's this minus 7?
43.
That's what it is, right? If 77s is 490, I want 69 7s, so I just take 1 7 away from this. That always works. So if I had 68 times 7, I would subtract 2 7s. I would subtract 14 from this. Really cool. I know a lot of you guys are saying, well, I just put it in a calculator. That's easy. No, stop. This is a real good way to be able to do that kind of thing in your head. Now, you can always, of course, just do this straight. But that's a really nifty way to do it. Quick. So that's 43. What does that leave us here?
45.
5. Here I need
1.
to
12.
borrow 1 from there. 45, and that's not bigger, so that's perfect. How are we doing so far? Okay. And then drop the 9. Good. So now you can do the same kind of thing. 70 into 459 would be, not 7, that's too much, it would be 6. So let's try 6. 6 might work. So if I put a 6 there. And notice, I made this point the other day. You put that number here at the last part of the whole number you're working with. You with me? If you put it in the wrong place, it's going to screw up any decimals you need later and so forth. Trust me. So you don't put the 7. I see people doing that sometimes. And then they get way thrown off what's going on later. So let's do the same trick here. What's 6 times 70? 420. Put that 0 on the end. I don't want 76s. I want 69 6s. So 420 minus 6, 414. I like it. I don't know if you guys are really with me on that. I don't know if you've ever been exposed to that kind of way of thinking about math. I mean, this is the stuff you can do with math. Math is not, this is the way to do it, do it. No, math is, here's some freaky stuff I want to know. Okay, there's a lot of ways to freaking do it. Right? What do you get here?
5.
5? 4. 45 again. And then I bring down the 6. So this is kind of cool. That worked here, so that's going to work here again. So it's going to be another 6. And that's sweet because I already know 414. Good, so that's 42. And remember, I don't want you going into the decimals yet. Some of you guys I'm not going to be able to rein in. I couldn't last semester. I had a few people that just did the decimals anyway. And the thing to be careful about is those decimals could obviously go on forever. So please, dear God, stop somewhere. Don't make that your life's work. All right? So right here, there's two ways to do this. You could either say R42. Or what I think in general is a slightly better way to do it is 42 over
69.
69. I love it. Now one little thing you have to be careful about, if you write this as a fraction, is can you reduce that fraction? What do you think? And this is going to lead me, now, get ready. This is going to lead me to another rant for a minute. Let me give you one example of what I'm about to talk to you about. Is that number divisible by 4? Yes. All I got to look at is this. If the last two digits of any number is divisible by 4, the whole thing is divisible by 4. That's freaky. Now, if you realize 4 goes into 100, that might not be so freaky. Because if 4 goes into 100, it definitely goes into 104. Right? Because that's just 4 up from something else it goes into, and so forth. You with me? Okay, maybe. So what does that have to do with this? Nothing. I'm getting there. Another little thing about numbers, knowing when something divides into something else. Have you guys ever seen this? Can I divide that by 9? Yes. What's the check there? Add them all up. If they add up to be 9 or a multiple of 9, 9 goes into them. Think about anything. What's 9 times 4? And what's 3 plus 6? What's 9 times 11? And what's 9 plus 9? A multiple of 9. With me? So any number that when you add up all the digits is 9 or a multiple of 9, 9 goes into that number. That's kick-ass cool. Again, I know. I'm just doing a calculator says it. No, stop. You can't let the calculator rule your entire life. You got to figure some stuff out, how to do these things on your own. So now getting to the point here. Neither one of those adds up to 9 or a multiple of 9. But if they add up to 3 or a multiple of 3, 3 goes into them. That's kick-ass. And so what's 4 plus 2?
6.
Okay, 3 goes into that. So 3 goes into 42. 6 plus 9? So 3 goes into that. So 3 goes into 69. So I can divide both of those by 3, simplifying that fraction, right? So if I divide by 3, what do I get here? 42 divided by 3? 14. And 69 divided by 3 goes into 6.
3 times.
Twice. 3 goes into 9. 3 times. Wow. Now, I desperately want to make this point. Very often over the first few classes, I'm going to go over something like that we're actually going to get a lot more in depth in later. So if you don't quite follow me in what I just did, we're going to have an entire section devoted to it later. So it's okay. I'm just exposing you to some stuff right now, yeah?
Only if you put in the fraction form to do that?
Exactly. So right now, the book says that's acceptable for right now. When we get into the fractions, that won't be good enough. Yeah.
Okay, got it.
But I wanted to show you, in case you do want to write it as a fraction, you better then follow it up with the correct form, which is simplified. Cool. Okay. And there's some other tricks here. 5 is the one that we already know. What does the number have to end in for 5 to go into it? 0, 5. So we all know that, but we all sort of have never been taught or forgot all the other ones. Okay. Anything else? Any other specific questions? Okay, so what I'm going to do is I'm going to lecture a bit on 1.7 and 1.8. I've got a few copies. How many of you guys have the binder blue book? Probably don't have enough copies, so we're definitely working in groups a bit later. So I'm going to lecture a bit on 1.7 and 1.8, and then we're going to do some group work on 1.7 and 1.8. All right. So don't only forget that problem. So I very often I distill history into something that's really workable. This is not a history and math class, but at the same time, it's really important for you guys to realize what went into creating the math that we now use. So the reason math is difficult for you is because you were born centuries after it was decided upon. Right? They had their whole freaking lives to figure out how to write up division. Now you guys have to learn it pretty damn quickly, relatively. Right? So I want you to realize that math it could have been entirely different. If you would have been alive back then, maybe you would have made a vote and changed it some other way. Maybe exponents would now be up here. I don't know. Right? So here's kind of the idea. If I had this, what's a more concise way to do that besides just adding them all up? What's a more concise way to capture what I've just written?
Multiply.
Yeah. Second.
Multiply.
Yeah. So I've got 1, 2, 3, 4, 5 4s. So a coefficient means the number of those things I have adding. So here's this poor guy, and you all are cool with dots meaning multiply? Be real careful. They should be very obvious to be decimals or dots. All right, so on a test or a quiz, just ask me if you're not sure. But this is definitely multiplication. This guy, he's like, I don't want to write all that. And he says, that dork over there already took 5 forward to mean adding. That sucks. So let me think. Maybe I could put the 5. No, it looks like division. Maybe I'll put the 5 big. No, that just looks freaky as hell. Right? I mean, it could have been anything. If you think about it, it could have been anything. You could have put a little box around it with a 5 there. You know, it could have been anything they wanted. Thank God they chose something simple like that. So that's not the universe coming and saying, humans, you will do it. No, this is humans making it up as we go. Not making it up, but representing ideas quicker. That's one thing about algebra and math. You realize you think mathematicians are lazy, and some of us are, but most of us just want to be efficient with what we're doing. So this guy used coefficients to mean addition. Now this guy says, hey everybody, and yes, they had cell phones back then. A little 5 up here means 5 of these things multiplied. Oh, yeah, that's a pretty good idea. And so everybody started doing it, right? And that's the history. Now, I'm going to come back to that later when we start talking about operations on properties of exponents. Do you remember, like, if you have x squared times x cubed, you add the powers? Remember all that stuff? All those properties come from just that one guy deciding to do this. All the properties of exponents come from this, period. So when we get there, I'll go through this little thing again, and then we'll shoot into the properties. All I want us to be able to do today is something like this. Can you write that in a more concise form? And I don't mean put it in a calculator and figure out what number is. Just write the idea in a more concise form. How would you write it in a more concise form?
7 to the 4th times s.
Good. I have 4 7s multiplying, so 4 7s multiplying times
S to the 3rd.
So yeah, you gotta love my writing. I know.
Okay.
That's
It
my
looks like
bad.
an S.
I don't blame you. I have problems with 3s and 5s. Yes, your math teacher has problems making 3s and 5s. Just do it. All right. But there's exactly like that. There's problems exactly like this in the homework. Just writing something in a more concise way. So if I did bring in variables, it's exactly the same way, right?
X to the 6 times
Yeah,
y.
you got 6 x's, so x6, y squared. I love it. Cool. Nothing major there. Okay. Now, when you start putting exponents, we've already seen this. When you start putting exponents inside of order operations, they've already got a predefined place that you do them, right? But we have to kind of know how these things work. There's one little thing I want to talk about real quick is negatives. I'm not going to focus a lot on this at the moment, but I want to give you a little shortcut how to deal with exponents on negatives. If I have a negative number to an even power, so if I have 4 negative 1s, every pair of negatives does what? Cancels out. Because negative truly does mean the opposite. Or I like to think of it as turn around. So if I have 1 negative on me, I face this way. Then somebody puts a negative on me, that means turn around. If you put another negative on me, that turns back, I'm right back where I was. Those 2 negatives cancel each other out. So any pair of negatives kills each other. So if I have an even number of negatives, the answer will be even. Positive. Right? Now here's the evil part. This is the part I think we saw an example earlier, or maybe not, I can't remember. What if I do this?
Same thing.
And this is why. Parentheses have a purpose here. These parentheses tell me that 4 is affecting both of these. Because exponents are really freaking weak. They can only interact with the thing right there. You with me? Parentheses kind of group stuff and says, here you go, dude. Act on all this stuff. So what is that's 1 to the 4th power, which is 1, with a negative sign. And I know students hate that. They're like, people tell us that even powers make it positive. There's an even power. No, it made it positive. It was positive already. It just has a negative sign in front. Right? Okay. Hopeful. So what if I did something like this here? Now what's going to happen? If I have an odd number of negatives, I don't want to flick you guys off. And 2 of them will cancel in this instance, right? If I have 3 of them, 2 cancel, so I have 1 left. So the answer is going to be negative. So you think to yourself, what's 2 cubed? 2 times 2 times 2?
6.
Careful. Times 8. So if I want to write this, I can actually write it like this. You can actually just kind of work it directly. Because what does something cubed mean? I have 3 of those things multiplied. So you can always rewrite. Now, please, dear God, if they put an 11th power up there, don't write it 11 times, right? Okay. But you certainly could do this third. Negative 2 times negative 2 is
4.
positive 4 times negative 2, negative 8. So that's showing you more directly that the answer will be negative. 2 negatives cancel. We saw that actually happen. 1 negative left alive.
So why is 8 again?
Because of the multiplication. 2 times 2 is 4, times another 2 is 8. Yeah. If it would have been this, now that's negative 6, right? Because now I have 3 negative 2's adding, not multiplying. Cool. Okay. All right, so how are we doing so far? Is that decent? Okay. Anytime we're talking about a topic and you have a specific issue, that the topic that's hurt you your whole life or whatever, let me know. We'll talk about it. Now, obviously, there's a lot more to exponents themselves, but this section really just wants to get you the basics so you're able to handle them when they show up in order of operations. So let's do this. Actually, maybe I want to do it up there. Maybe not. If you have your little blue book, I might try this sometime, but maybe not today. Sometimes I put them on the overhead and I might try to work them out, but this room is not set up the best for that. Because I don't think you guys could probably see it all that great. But here's your blue book. They finally number the pages, so on page 16. I just want to do some order operation stuff together. And then I'm going to let you guys work on the first part of the group work, section 1.7. I'm going to go ahead and let you guys work on just that part. Then when that's done, we'll do section 1.8, and then I'll let you guys work on the group work for section 1.8. So you're not listening to me talk for too long. All right, some of you guys might think it's already been too long, Jeff. Let's start off really kind of nice here. So now I just want to focus on looking at some order operations problems.
You're going to do 6 times 4, 32 minus whatever that is.
Yeah, so your operations here are subtraction and multiplication. So which one do you have to do first? Multiplication.
Multiplication.
So you get 32 minus 24? 8. I love it. Let me real quick, let me give you, this is Jeff's own little problem here. And I would only do this to you right now while I can talk to you. Because it's not a trick question, but it is definitely one of the hardest order operations problems ever. Some of you guys will think I must be joking, and that's the trick. Maybe I am joking. But does anybody have an idea, a guess as to what that is?
One.
Okay, so I get some ones. And those are the people that think, you must be joking, Jeff, that was pretty damn easy. And I might be. But remember, what is it about multiplication and division? What did I try to make a big point of on that first day? What is it about multiplication and division?
Goes and goes.
Nope, I never said
Goes
divide
and
first,
comes.
ever.
Parentheses first.
Yeah, it'll matter.
You go as it
Now,
comes.
let me make
from
that.
left to
Let
right.
me address that real quick. In order operations, the please means things in the parentheses. What operation does this parenthesis really imply here? What operation is that parenthesis saying?
Multiply.
Multiply. So it's not. This won't end up in parentheses. This is multiplication. You with me? Is there anything to do inside there?
No.
No. So that's not on the P level of PEMDAS, right? It's not parentheses. So there's only multiplication and division. You do it as it comes.
All I know it is.
So it's 4 times 4.
16.
Maybe? Let's see. 4 times 4?
16.
16.
Divided by
16 divided by 4?
4.
4.
Times 4.
4 times 4? 16. Now, I desperately want, I know some of you already hate math. You're in here and you're like, there's a really good example of math screwing me the hell over. I want to make sure you understand, this is human nature to see this division as a dividing line and say, I'll do that side and I'll do that side. This does not say this. That would be 1.
Yeah.
What's this dividing by 4, not by both of these? If I really wanted to set this up like that, it'd be 4 times 4 divided by 4 times 4. So there's still only 1 4 on the bottom. Okay, so again, what did I say? This is one of the most evil little things. It's really easy to make that mistake to say it's 1. Crazy easy. But multiplication, division as it comes.
I was going to say, like, you could even make because the 4 in front of the parentheses is multiplication, and it says there's nothing to do in the parentheses. You can even just drop the parentheses and put
Yeah, you can put little dots in there.
put a multiplication there if the parentheses confuse people.
Exactly, cool. So you can replace this with just a dot, just so you don't think it's parentheses. Yeah.
I really don't know what I'm trying to ask, but why did you put 16 on the left side and then 16 on the right side?
All right, let me do this again. Hold on. Let me write this in a little different way. Okay, so if I had to do this problem, you would do this up here first, right? That's 16. What would you do next? 16 divided by 4? And that would be 16. That is the same as this. Those are the same problems. If I want to write, let me see. If I want to write this problem, now let me say this real quick. See that big bar in the middle? That makes a lot of things very clear. That if I try to put it in one line, I have to put some more symbols in to make that still clear. That big bar says, this is top, this is bottom. Right? If I put it in one big line, what the hell's top and what the hell's bottom? I've lost that. So if I want to make sure this is top and this is bottom, I have to do this. Right? In fact, to be really, I have to do this. Top, bottom. Right? You with me? Because then what would order operations say here? It would say do in here first and here. Do that last because it's outside the parentheses. You with me? So that would be this. So let me give you another one here real quick. Let me see if one does what I want it to do. Not yet. So here's a quick little example that's a little bit easier than that. This is definitely one I would give you in a test or a quiz. I'd give you this no problem. Almost. So what do you do first?
Divide.
Yeah, divide. So please try to catch yourself. Anytime you say multiplication before division to yourself, have a little something on you, snap. You ever see somebody with a rubber band? Snap. Do something like that. Get that out of your head. It's really too bad. Some teachers actually teach that, which is really evil. Because it's not true. You do these as it comes. You do these as it comes. So this I definitely do last, right?
Right.
So this 4 minus, let me not put too much other crap in. 4 minus is just going to come for the right. 4 minus, I don't know. So here, it's all division multiplication. You do that as it comes. 9 divided by 3.
3.
3. So that times 5 is still there. 4 minus 15. Beautiful. And the thing about sign numbers, if they're different signs, I think they said this in the first day, but let me say this again. If they're different signs, see how this is a positive 4 and a negative 15? You subtract them. 15 minus 4 is 11. And you put the sign of the bigger one on. If I had $4 and I owe somebody 15, I can pay them off only so far. How much do I still owe them? I owe them $11. So taking this to money very often hits people pretty directly. They're like, I'm used to thinking that way. So that's exactly the way I can look at this. I have $4. I owe somebody 15. I still going to owe them $11 after I pay them off, and I can't eat lunch that day. Check. Right? Okay. So let me do this. Let me let you guys work on this first collection. So if you have the book, it's page 17. If you don't, let me give you. If you're sitting near somebody with a book, in fact, do this for me. Everybody kind of get a little grouped up with somebody else.
Anybody not have a book? I have a book.
There you go. So if you happen to be sitting near somebody with a book, kick ass. If you want to group up with somebody, neither one of you have a book, don't freak out. I'll give you a copy.
Yeah.
How do you write 4?
Oh, you got a book.
I'm going to go over here.
Okay. Anybody back there? You guys need a... Back there, here, here's one more copy to help you guys out. You guys want to have books? You guys okay back there? So this is page 17. If I gave you a copy, it's the exercise 1-7 practice. Just start working on those. Call me over if you need some help. I think somebody just want their own copy now. I think everybody has at least one. Just ask one. Oh, just a second. All right, everybody's good? Okay. Oh, no, yeah, it's in the little blue binder book.
So, yeah, we would define the fourth times. That's 64.
Here you can simplify it, like having the 4 to the power.
Oh, just that.
Times.
Don't give me the big number.
And then you can simplify it.
The instructions would say, I think the instructions are very clear here. This
Well, 4 times.
if they said simplify, that actually does mean give me the number. Simplify means do all the
Here
Here they're being very specific. Don't do all that first one. Just right now, you each need to have your own. Actually, probably not, because you can put it in your homework. I'm not doing this work. We'll talk about
I know, that's what I do.
Yeah, just make sure.
Oh, no. 27. Yeah, 27. And then 64.
So now, just like you did 4.
I remember this. How many 21s are when I started getting
I got 1,000.
I know how to do this. So
Yeah.
Oh.
So like I'm saying, I have 181. We got 81. If I had 281, that's game 32.
So you saw 4 times.
So that's gonna be 64.
So now you're doing this one.
But I was trying to,
Or if there was
so I'm doing this
times
for
4,
times
times 4, which is just multiplication. We're going to do multiplication. We had to remember.
Yeah.
So do this first. You do this first. And then you times whatever 3 third power is. So 3 times 3 times 3. So 3 times 3 is 9. 9 times 3.
When you have that,
So 3 times 3, right? So, which is 9. So, and then 9 minus 3.
Yeah, sorry.
4 times 3.
Okay, for that, and then the 0.
Now,
And then 2, and then 4. Yeah, there you go. So 1, 441, right? Times 21 again.
so like,
No, you finished multiplying the 1. Oh, the 3 all 3 numbers.
another 3 would be. That's right, but right now, all my
Times 21 again.
How many 7s? 2. So I can rewrite this as multiplication. I can write this as, I have 4 7s. So that's a more quick way to write it.
because he wants to
All
see.
these words are write 7
He wants you to show the difference by breaking it down.
So I can write, if I have 21, I have 4.
You got this number right there. So this is 21. Oh, you got that.
How do I get back there? This room is insane. Oh, just 1 second.
So 1, 6, 2. Yeah, because you were trying the 1.
Oh, yay. We get the same number, basically. After that, 2. Yes. I'm looking at it upside down.
Yes, sir.
Yeah. No, actually it's 12.
Oh, no, just exponential. So if they would have just said evaluate or simplify, then I want to see just the number at the plus. But this specifically says just write it in a more compact form like that. Okay. You don't have to multiply. All right.
No, it's
Because 2 times
4 plus 1, 5. So you should get 5. Wait. No, let's start again.
So 2 times 1 plus 2
2 times 12.
and 12. 2 and
You
9
got 1. So 2, 4 plus 1,
Take those.
5.